Welcome back. The same integration was asked IIT JEE main exam as well as MIT Integration B qualifier exam. Now, after looking this integral, the start is very easy. You can start dividing numerator as denominator by e raised to x, or what you can do, you can adjust in numerator e raised to, here we have e raised to x, you can adjust e raised to x plus e raised to x as well as minus e raised to x. So you can start one of the way. The start is very easy. Now let's start. Is equals to, so I will do one thing, I will adjust e raised to x in the numerator only. So I can say it's e raised to x minus e raised to x. There 1 plus 1 is there, this one. So I have e raised to x plus 1 dx. So this upon this and this upon this. So this is same as, so 1 plus e raised to x upon e raised to x plus 1 minus dx minus integral e raised to x upon e raised to x plus 1 dx. Limit is from 0 to infinity, 0 to infinity, 0 to infinity. Now this gets cancelled. What we have? We have is integral is x. We have integral dx is here x. We have, and here integral is what? Differentiation of denominator become numerator, that is log of minus log of e raised to x plus 1. Limit is from 0 to infinity. Now this, can I write like this? This is same as limit of, here let's say some m, okay, m tends to infinity. Here if I write, so x minus log of e raised to x plus 1, and limit is from here 0 to m. So I am defining an m over here where m tends to infinity, therefore this is same as this. So now let's substitute upper limit minus lower limit. Limit of m tends to infinity, instead of x you write m here, m minus log of e raised to m plus 1 minus 0, okay, here 0 minus log of e raised to 0 is 1, here 1 plus 1 is 2 over here. We have this and we have this, okay. Therefore m tends to infinity, this becomes 0, okay. So therefore 0 minus, so minus minus plus log of 2. Therefore that is, the answer is what? Log 2. This is the required answer.